Okay, anybody come up with any solution on the puzzler? On how to do it?
Well, I don't think they can, but
I was gonna say, what if they start with D first?
Start with
A
D
should
first.
be last. A should be last, probably. And then maybe B should be second to last. So maybe if they do DCBA.
But you got to remember that if this is the bridge, you have A, B, C, and D on one side. They're trying to get to the other side.
Mhm.
And remember that the flashlight, if let's say D goes over with the flashlight has to come back. Because then nobody over here could go because you can't go without the flashlight.
What if they kind of like, and only two can cross the bridge at the same time?
Yep. Let me give you the solution and we'll get on to what we're going to talk about today. The first go around, A and B, let me do it this way. On the first go round, A and B go across. So A and B go across. That takes, because it's the slower of the two, 2 minutes. But then A comes back. So we leave B. Come on. We leave B over here. And A goes back, which takes 1 minute. Then C and D go across. So that's a grand total of 3 minutes so far. C and D go across. The slower of the two is 8 minutes. So that takes 8 minutes. We end up with C and D over here. And B goes back. So the B is going back. So all we're left with over here is C and D. That takes 2 minutes to go back. And then on the last pass, A and B go across in 2 minutes. So we've got 2 minutes plus 1 minute is 3, plus 8 is 11, plus 2 is 13, plus 2 is 15.
Why can't A be the one to go back every time?
Because you only have A only, once A and B go across, we have A and B over here. A goes back, so A isn't there anymore.
Yeah, I'm saying like instead of having like B being the one to go back, why can't A just walk them all across then?
Because that would take longer.
Okay.
Because if A walked B across, it would take 2 minutes. And then A came back, that's another minute. Then A walked C across, that's 5 minutes. And A walked back, that would be another minute.
Okay, I
and
got
A walked D across, then that would be what? 8 plus 5 is 13, plus 2 is 15, plus the 2 or 3 trips back would be over 15 minutes.
Okay, I gotcha.
Okay. Now that we've woken your minds up, I hope. When we left off last time, we were looking at, I just realized I didn't open that up. Let me grab that quick.
Huh.
All right. So I think we left off with this problem, and I said this would be a problem that we'd solve, and what would we do in this case? I think, Natasha, you had asked if is it just for checking. So
yes, but also I'm not seeing the problem, sir.
Oh, I shared that. Thank you.
No problem.
Okay, so that's where we left off. We were talking about what would we do if we had a problem where we had an unknown resistor, but we were given, some other information? Could we solve that problem? Before I do that, let's go. Oops. Oh, wrong one. Gotta go back to the other one.
The last program the last like problem we were looking at was like it was like from A to G and then ground.
Right. So it was this one. Nope, that's A to D.
Mm-mm.
That one.
Yes, sir. A to G. There it is.
Yeah. So we had done this one. Then we talked about the second form of Kirchhoff's voltage law, which instead of saying the resistor voltage is equal to the applied voltage, we said if we go around a closed loop, making sure we start and end at the same point, that it all adds up to 0. So we figured out also that it didn't matter where you started. You could start, I always usually try and start at the top of the source and go around, but it didn't matter. You could have started anywhere you want. So I had you actually do it at C, and we found out that it added to 0. And somebody asked about clockwise or counterclockwise. So we actually did it counterclockwise from C, and we still ended up with 0. So it doesn't matter. The key thing to remember is that there's 2 things. Number 1, you have to remember where you started, because that's where you're going to end. And the second thing is, as you go around the loop, you're going to pick the polarity that's the first one you come to as you're walking around the loop. So it would have been plus, 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 minus as we went around that loop. Okay, so let's, I want to do one thing before we get into the kind of problem I just looked at, just to wake everybody up again. So what I'd like you to do is just solve that problem. Solve for REQ, IT, and all voltages.
Sorry, Professor. I think maybe you got voltage of BC incorrect.
All right, I'll check it in a second.
Okay.
A third of 1.63. I think, unless it's math. Hold on. 330. Yeah, how do I get that number? That look better?
Yes.
Thank you.
Thank you.
Picking up on that. All right, let's take a look at it. You should have had enough time to at least get through most of it if you didn't finish it. So remember, if we're doing a series, first of all, confirming it is a series circuit, current that leaves the voltage source has only one place to go, into R1. When it comes out of R1, it's got only one place to go, into R2. Comes out of R2, the only place it can go is into R3. Comes out of R3, the only place it can go is into R4. Out of R4, the only place it can go is into R5. Out of R5, goes into R6. Out of R6, it goes back to the source. So there's no place that it can split. So if I had something like this, okay, let's say there was another resistor over here. When the current got to here, it could split. Part could go this way, part could go that way. That means that we're no longer in series. So if I see 3 connections, 1, 2, 3 connections at any node, this is called a node, 3 connections at any node, I know that it's not a simple series circuit, okay? As long as I've got 2 connections, one from this resistor, one from this resistor, connecting to B, I know I'm good, okay? All right, so it is a series circuit, so the first thing we do is add up the resistor values to get our EQ. Remember, and I'm mentioning this because of the exam later, remember, you always want to show, for any formulas you do, the formula, the numerical substitution into the formula, and what the result is. So I can go back and check your work, all right, if you come up with a wrong answer. So in other words, on that one, I just did wrong. If this was an exam and I was grading it, I would have said, yeah, right formula, right substitutions, came up with the wrong number. That says that there's a calculator error, which is minor compared to if these were wrong, all right? So formula, substitution, result. When I do that, I redraw my circuit showing the REQ of 6,160 ohms or 6.16 K ohms. I can't solve for anything in this circuit right now because the voltage that's here is not for R1, not for R2, not for R3, not for any of the individual resistors. It's for the whole thing. So I can't solve for anything. But once I'm down to here, I only have one source and one resistor. So I can solve for the current, and I can figure out that that current, when I do Ohm's law, is 1.623 milliamps. Okay? And that means that I've got 1.623 milliamps flowing in this circuit. And in a series circuit, remember, one of the rules for a series circuit is the current is the same in each one of the resistors. Current doesn't change. So when I say that 1.63 goes through 1K, I get the voltage across here, which would be 1.623 volts, plus on the left, minus on the right. When I take the 1.63 IT, multiply it times R2, I get 0.535 volts. Current goes in on the left, plus is on the left, goes out on the right, so the minus is on the right. That IT times R3 gives me 6.331 volts. Current goes into the top of the resistor, so that's the plus. Comes out of the bottom, that's the minus. IT times R4 gives me 0.4383 volts. Now current goes into the bottom here, so that plus is going to be at the bottom, and it leaves at the top, so the minus is at the top. R5 times IT gives me 0.1623 volts. Current is going into the top. That makes that the plus, leaving the minus, the bottom. So that makes that the minus. And then the current goes into the right-hand end of R6. That makes that the plus. Comes out on the left end. That's the minus. When I multiply IT times R6, I get 0.9091 volts. Okay. Everybody good? Any questions on that? Hopefully by now this should be old hat. Okay, so let's go back to where we left off last time. That's today. And the question was raised, is that just to check? Oh, and we didn't do Kirchhoff's voltage law, but I'm pretty sure that if you add them up, they'll check out. I want to go into this circuit over here and see how would we solve that. And one of the ways you can do this is to set up a little table. and see if you know the voltage, the current, and the resistance. So if we put in what we know that the VS is 20 volts. We don't know what the current is. The resistance doesn't apply. For R1, we know that the voltage, the resistance is 680. Let me do this so we don't lose track. For R2, we don't know it. That's an unknown. R3 we know is 1K. R4 we know is 100 ohms. And we also know that the voltage across R3 is 2 volts. So where do I start? Any ideas? I can't take the approach I've done before and say add up the resistors and divide into the voltage to get IT, because I don't know the value of R2. So where do I start?
Even though you don't know. Oh, wait.
Let me ask you a question to sort of prod your memory a little bit. We know that Ohm's law is V equals IR. I equals V over R. R equals V over I. So to solve this three variables, right? Voltage, current, resistance are my 3 variables in each of the equations. In order to solve for any variable, how many unknowns do I have to know?
2.
You have to know 2. You have to know 2. So if I look at this in here, is there anywhere where I know 2 of the variables?
No 3 and no 4.
Well, for R3, you know, voltage is 2 and the resistance is 1K. R4, you don't know the voltage, you don't know the current, but you do know the resistance. So the only one I can work with is this one here, because of the fact it's the only place I know. Here I only know 1. Here I know nothing. I shouldn't really, this doesn't even belong here. Here I know 1. Here I know nothing. Here I know 2. Here I know 1. So from this, the first step is to find I. So I could say that I sub R3 is going to be equal to V sub R3 over R3. And that's 2 volts divided by 1K, or 2 milliamps. Right? And we know the 2 volts is associated with R3, so we're going to use the value of R3. So now I know that this is 2 milliamps. And that's a game changer. Why?
Because now you know the current of every single one of them.
Now you know the current everywhere. So this is 2 milliamps. This is 2 milliamps. This is 2 milliamps. And this is 2 milliamps. And all of a sudden, we know 2 variables here. We know 2 variables here. We know 2 variables here if we want to find power. So what can I do next?
Anyone you want. You could do R1 if you want.
Okay, so if I say V sub R1 is IR1 times R1, or rather IT, let's call it what it is. IT times R1, so we've got
6.
2 milliamps times 680
I'm sorry, 1.36.
1.36 volts.
I'm seeing K over here.
Did you remember the milli?
Oh, no, I didn't. Thank you. I was like, that doesn't make sense.
I have the same problem too.
Wait a minute. What were your last words, Natasha?
I said, I did not remember the milli. I was like, that didn't make sense though.
Keywords. That didn't make sense. I wish I could get students to say that, ask that question, and I really emphasize it a lot in my physics courses when I taught physics and in this course. When you come up with a number, you got to ask yourself, does that number make sense? And coming up with 1.36 kV, kilovolts, from a 20-volt battery does not make sense. We know that if all of these have to add up to 20, each one of them has to be less than 20. So kudos to you. Good job for picking up on the fact that it didn't make sense when you came up with 1.36 k ohms. Okay, so that was R1. So this was 1.36 volts. Now what else can I solve for?
V of R2. Wait, no. V of R4.
V of R4. So you've got IT times R4. So I've got 2 milliamps times 100 ohms. That should be like 0.200 volts or 200 millivolts.
Yeah.
Wait, that was a given. I'm trying to use different colors for given versus. So now what do I do?
You can like add all the voltages that you have and compare it to like 20. So for example, you could do 20 minus the known voltages so you could get the unknown voltage.
We could do that. Let's get all geeky here. Using what law?
Something Kirchhoff's, like some of the
Kirchhoff's voltage law.
yeah.
That's what you meant.
Yeah.
I knew that. Kirchhoff's voltage law. So if we using KVL, to find V sub R2, we can say that, let's do it this way. V applied is equal to VAB plus VBC plus VCD plus V sub D. So we applied 20 volts and VAB was 1.3. Well, let's do this. Okay, so when we plug in to a formula like this, you always want to check your polarities. So VAB was 1.36 volts with plus on the left, minus on the right. Why plus on the left?
Because if you look at the source, you see the long side is on the top.
And
So
that means
positive voltage is on the top and negative voltage is on the bottom.
yes. But let's think always, whenever you're thinking about polarities, try and remember, look at the direction the current is flowing. So the plus over here means current is leaving and is going to circulate through the circuit in a clockwise direction in this particular case. And the current goes into the left end, which makes it the plus. When you get to R2, that goes into the left end, which makes that the plus. When you get into R3, the top makes that the plus. Goes into the right-hand end of R4, makes that the plus. So think about your current direction to find the current. So we are adding a positive, and when you're looking at the subscript, the polarity of the first subscript, that node, is the one that determines whether you put in a plus or a minus. So right now, A is at the positive end of the 1.36 volts. So we would write that as plus 1.36 volts plus VBC. We don't know what its value is yet, so we'll just write it as VBC, plus C to D, it's VCD. C is the plus end, so we'd write that as plus 2.00 volts, plus VD, D to ground, D is at the plus end of the 0.2 volts, so we would write that as plus 0.200 volts. And if you work all of the math, you get 18 minus 1.56. How about 16 point? Is that right? 18. Yeah. 16.44 volts.
Mm-hmm.
Yeah.
Yes, sir.
So now we know that we've got 16.44 volts, and it means that now we can say that R2 is going to be V sub R2 over I sub R, or IT. So we have 16.44 volts divided by 2 milliamps. So that works out to be 8.22 k ohms. Did everybody follow the process that we used? I would probably say take and set up a table, all right, that's got your values, not IT, but VS and the resistors. Have a column
You
for
don't.
voltage, column for current, column for resistance, and then put in what you know. So in this case, we knew the 20 volts, we knew the 680, we knew the 1K, the 100, and we knew the 2 volts across R3. And in order to solve for anything, you have to have a row that's got 2 out of the 3 present. Generally, as a rule, if you can find the current, that's great because it allows you to solve for, it allows you to solve for or put in a variable for everything. We good?
So you
Yeah.
don't have to convert the milliamps when you divide by the 16.44.
Down here?
Yeah.
Yeah, I would have entered this as 16.44 divide by on the calculator. 2.00 second EE, change sign, 3, enter. All right, so this is your
Okay,
milliamp,
I got it. Yeah.
all of this, rather. Of course, well, yeah. Once, just as a point of information, if this was my problem, when I was over here, let's look at this one for a minute. Once I came up with that number, what did I do with it? Wrote it down somewhere, memorized it, what did I do with it? Hello? Anybody awake out there? What did I do with that number? When I came up with 2 milliamps, what did I do with that number right off the bat?
Wrote it down.
You could write it down, but what's the better way to do it? In your calculator that we talked about last class.
You could store it.
You could store it. That's exactly what you want to do with it. And especially that number, because if you think about that number, 2 milliamps is easy. We could have written that down. But if this had come out to be some ugly number, we would have been putting that number in all the time. Whereas if I store this as 2 milliamps, I'm going to use it here. I'm going to use it here. I'm going to use it here. So I'm going to use it a bunch of times. So rather than re-enter it all the time, store it, and then you just do second function recall. Now, I really liked Ronnie's idea yesterday. Store it in alpha I because it's the current. So store it in store alpha I, and now you've got this number to use whenever you want it. We used it here, we used it here, we used it here, and I don't have to keep re-entering the number all the time. Okay. Other questions on that? All right, so that was the problem we looked at last class. So let's do this. Try that one. Set up your table like we did, and then do your calculations to complete the table.
Sorry, Professor. Is that a V meter telling us the voltage of R2?
Okay, yeah. So let me very quickly go through this. So if you've got this is a voltmeter. Remember, we talked about voltage across,
Current through?
current through. So the meter is measuring across the resistor. So that's a voltmeter. It tells you it's a voltmeter here, and the value it's reading is here. Okay. I'm going to give you another problem later on that looks like that. And now this is an ammeter. We see that it's an ammeter, and it's connected in series with the resistors, not across the resistor, but it's in series. So this would be the current for this resistor or this resistor. And since we know about series circuits, it's the current in the whole circuit as well. But yeah, so this is an ammeter, and that's a voltmeter measuring across.
Okay. Thanks.
Let me do this very quickly. Let me ask you to complete this for homework. All right. Does everybody have the circuit drawn?
Hang on.
Take a minute to draw the circuit because I'm going to give you a second one.
Okay.
So what I'm going to ask you to do is either scan it or take a picture and email it to me by Monday, the 26th at 3 p.m. so I can look at them and see where we're at. And then the second one is here's a second problem that's a little different. See if you can solve this one. Again, you have an unknown resistor. In this case, it's R1. Let's see if you can solve that one.
We're sending over the second problem as well.
No, you don't have to send that one because we'll talk about that in class on Tuesday.
Okay. Okay. And you said send you the first problem by 3 p.m. Monday so that you could grade it for class, you said?
Yeah, I just want to get a feel for where everybody is. Well, I'll grade it, but I mean, I also want to see if people are, because that'll tell me whether or not I got to spend more time on this so we can move on to other stuff, other kinds of problems.
You just need to find the missing resistor or the whole voltages or all resistors.
The answer to that question is yes. Because if you think about it, you're not going to be able to find the unknown resistance until you find the voltages.
Can you quickly go back to the other one, please?
Sure.
Just-
Before I do that, does anybody need more time on this one?
Yeah, I need.
Wait, what are we doing with this problem, sir?
Solving for, you know, that table that we completed that we set up? Set
Yeah.
up a table and then complete whatever is not given in the table.
So this is question 2, or the other one was question, like, this is question 2, right?
This is
Or
question
was
two with the ammeter. I'm pointing to the ammeter like you can see me point. Yeah, this has got the ammeter. The other one had a voltmeter.
Oh, okay, so we're solving both things then. Okay.
Yeah, you're solving both, but only sending the one with the voltmeter.
Oh, okay.
We good on this one? Anybody need more time?
Yeah, just give me 1 more minute.
Okay. If you want to, on your paper, to make life easier, you could do R1. Just indicate milliammeter. Over here is R2. And write 4.545 milliamps. You don't have to try and draw this thing. Similarly, on the other one, you could have just drawn a V with a circle around it to represent the voltmeter.
All right, I'm good now.
Anybody else need more time?
Mm-mm.
All right, let's go back to this one a minute because somebody asked about this. So again, on this one, you could just have done
Professor?
Yeah.
Can I just see the table when everybody's done with this one real quick?
Table from a previous one.
Yeah, I'm just gonna take a
Okay.
picture of it.
Is everybody good on this? Anybody need more time? Oh, you know what? That's on the other. Hold on. So I just set up a table with VS, R1, R2, R3, R4, a column for voltage, column for current, column for resistance. What we're going to see, just so you are aware of it, we're going to add another column over here with the power. So there'll be 4 columns. For now, we'll just use 3. But next Tuesday, when we get back to doing problems, there'll be voltage, current, resistance, and power. And probably
Thank you.
thinking about it, I would probably make this the resistance column since they're right next to the R's. So resistance, voltage, and current. It doesn't matter the order, just so long as you got them all on the table. Okay. Anybody else need more time on this one before I go back to what I was going to talk about? Okay.
Mm-mm.
Okay, let's talk about the exam for a minute. The exam covers chapters 1 through 4. I mentioned that before. That's the prefixes, the units. If you looked at the review video, the video of the review class yesterday, it pretty much goes through what we're going through. One thing, calculators are calculators. You cannot use a phone or an iPad or anything else. You can only use a calculator to do the exam. Okay. My exams are 2-part exams. So part 1 is multiple choice. And it's all conceptual. So I may ask you things like the designator for current is, and expect you to know it's I, or the units for resistance is the ohm, that kind of stuff. The idea about some of the stuff that was in the textbook might be in the multiple choice section. So that's strictly conceptual. Part 2 is the calculations. So calculations might be converting something from microamps to milliamps, or from mega ohms to k ohms, or whatever. That's the part with the prefixes in it. It'll be the Ohm's law calculations in the various forms of Ohm's law. It'll be power calculations. So that's in the calculation section. I always do a 2-part, and I explained this at the review session. It all started when I was teaching a physics course, and I happened to have 3 of my ELT majors in this physics course. And probably they were running about a 68 average. At that point, my exams were strictly all calculations. And they were probably running about a 68 average between the 3 of them. And we were in a lab, and I had this other group, and among those 3, they were probably running about a 90+ average. And the one group that was running the 90+ average called me over and said, our lab's not working. And I said, okay. I said, what is it supposed to do? What should be happening? And they just sort of looked at me. And one started to reach for a calculator. I said, no calculations. Just tell me what should be happening in this experiment. They couldn't explain it. Just so happened that my ELT guys had the same problem. And I went over to them and I said, well, what should be happening? And I said, well, it should be doing this and doing this and doing this and doing this, but it's doing that instead. And that, we know that that's not right. And I went, what's wrong with this picture? I said, that group, I'm thinking to myself, that group over there is running a 90, have no clue as to what they're doing, but they can crunch numbers. And this group, which is running a 68, knows exactly what's happening, understands what's going on, but can't crunch numbers as nicely, so they're not doing as well. So I always have, since that point, modified my exams to always have conceptual questions in. Show me you understand what's going on, as well as part 2, be able to do the calculations. So what'll happen is you'll get the questions and a Scantron form from Professor Atwood. When you finish up part 1, you give him back the Scantron form and the questions. and he will give you part 2. And then you do the calculations for part 2 using a calculator. All right?
Do we
Yeah.
need to bring like a pencil since it's a Scantron?
It can't hurt. I don't know whether or not, I know I have pencils in my bag with me when I give an exam. I don't know whether or not Professor Atwood has a stash of pencils with him. So probably it might not be a bad idea to bring
So like a number 2 pencil, kind of like standard type thing.
a number 2. It's also called HB if you have a drafting half millimeter lead pencil.
Okay.
So if you have a mechanical pencil, it's probably HB. If you have a wood stick pencil, it's probably number 2. Those either one will work on the Scantron.
Okay.
Okay. Any other questions on the exam?
Is it you just finish and go home, or
I don't know when he's giving the exam, whether he's going to give it at the beginning or whatever. All he did is he offered to proctor the exam, and I jumped on that since, you know, if I can stay at my age, if I can stay in crowds of people, I'm going to do that. I don't know when he's going to run the exam, whether it's going to be first thing and go home, or first thing and you're doing a lab, or you're doing a lab, then the exam. He will let you know that when you get there.
Is it time? Like, did you give him a certain time that we should have?
I gave him about how long it took me to do the exam. When I did the exam, I gave him the, you know, what it took me, and I usually double whatever it takes me to do the exam for students to do the exam. I
Fair.
gave him those times, and I assume he's going to go by them, and I don't remember what they were off the top of my head, so he will also have that information. Other questions?
how many questions are on the exam?
Yes. I don't remember off the top. There are certain things that go right out of my head when I'm done, and the number of questions on an exam is one of them. I just made up 2 exams. I gave an exam in my morning class, and your exam, and I don't remember off the top of my head how many are on each one. But you'll have enough time to do in either case, no matter how many there are. Okay, if there are no questions, then what I'm going to do is I'm going to let you out a little bit early today, so you have plenty of time to get over to campus. Make sure you bring a calculator, and if you've got a pencil handy, bring it, and we'll see you all on Tuesday.
All right, last question.
All right, take care.
Bye. Thank you.
All right.